Welcome. Welcome to new module, structure, union and bit fields. Structure, union and bit fields. So we'll discuss this as separate sessions. First we'll start with structure. What exactly is a structure and how to represent it, how to access the contents of the structure, and for what purposes we are going to use the structure. If you remember, we discussed about array. So an array is a homogeneous collection of elements. 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 What do you mean by homogeneous? What do you mean by homogeneous? So homogeneous means elements of the same type. Elements of the same type. Same type in the sense that here we are interested in same data type. So an array is homogeneous collection of elements. There are elements of the same data type which have a common name. The elements of the array can be accessed using what is called as indexing. So for indexes, in the case of array in C language, we use integers. So marks of a student in a particular subject, they can be represented as an array. Okay. So the elements have same attributes and the operations that are performed is also similar because they belong to same data type. The operations that are performed are also similar in the sense that you can perform different operations on the different elements of the array, but there will be a overall restriction. What are the operations that can be performed? That will be restricted. What are the operations that can be performed? That is restricted. So if it is an integer array, you can, with the elements of the array, you can perform certain operations. But you can add to some elements, you can subtract from some elements, that you can do. So, but addition and subtraction both should be permitted operations. So it depends on the data type. Of the array. But in the real world, there are different kinds of data. And sometimes we need to group such data. If you consider a typical office, any government office or private office, they maintain what is called as record of information, of course in the form of files. We'll get to that one in the next module. They will maintain the information in the form of records. A record of information. Usually, if you go to a government office, every person will have a record. Or every land will have a record. It will contain different information, maybe the name of the owner, where it is located, what is the market value, etc. in the case of the land. So we maintain information in the form of the records. Now we cannot represent records using arrays. Because it is a homogeneous collection of elements. So if we consider, say, the name of the person, the location of the land, market value, etc. They are of different types. Name can be say sequence of characters. Location may be represented using floating points. Market value may be some integer. So like that, you have different types of information, but these different types of information are brought together. There are different types of information, but these different types of information are brought together. Okay. So for another example is a student record. If you consider, it consists of a roll number, name, address, marks in different subjects. Roll number may be a character array. It can be sequence of characters. Name is sequence of characters. Address is also a sequence of characters generally. Marks, they can be integers or real numbers. like that. Maybe again class may be there, grade may be there, say A, B, C, D, which are of type character, So we have different types of information, but there is logical relationship between this type of information. So what are these marks? Marks of a student with some roll number. Marks of a student with some roll number. What is address? Address is nothing but address of the person with name, say name, with name, and then with the identification given in the form of roll number. So you have different types of information. How do you represent such information? How do you represent such information? So the record of information is represented in C language in the form of a structure. So such record of information is maintained in the case of C language in the form of a structure. So now what is structure? So a structure is nothing but heterogeneous collection of elements. It need not be heterogeneous. Sometimes it can be homogeneous, but maybe it is little confusing. We will strike it off. So a structure is a heterogeneous collection of elements. Heterogeneous implies sometimes homogeneous is also possible. Okay, a structure is a heterogeneous collection of elements. That means it is a collection of elements where each element can be of different type. Okay, they can be of different type or they can be of same type also. Some of the elements are usually of same type. All the elements maybe are of same type also, but it is a heterogeneous collection of elements in general. Consider again the student record example. Roll number may be represented using integer, name and address are represented using character arrays. Marks in individual subjects may be represented using integer or real. So like that. So C language supports record using structure. A structure is a heterogeneous collection of elements. But of course, why should we have structure? If you consider this roll number, name, marks, etc., all this can be represented as separate variables. You can have, say, roll number, name, address, mark 1, mark 2, etc. But one thing that will be missing is logical relationship. As I already told you, marks of say mark 1, mark 2 are marks of a student in two subjects with roll number, say some X. Similarly, address is the actual address of the student whose name is given in the as attribute name and also identified with the roll number. But that logical relationship between them will be missing. So because they are logically related, we bring together and we call it as a structure. So the better option is to represent them using structure. So a structure, I am trying to redefine the structure. A structure is a heterogeneous collection of elements which are logically related. Maybe you can take this as the definition. A structure is a heterogeneous collection of elements which are logically related. If they are not logically related, then there is no meaning in bringing them together. Okay, structure is a heterogeneous collection of elements which are logically related and maybe which are brought together. That also you can add. A structure is a heterogeneous collection of elements which are logically related and which are brought together. So how do you define a structure? Okay, C language implements it using structure, but how do you define a structure? So it is defined like this. Struct tag within the flower brackets, you will be defining the fields. What does it mean? Struct is a reserved word. If you consider struct is a reserved word. So you have to use as it is. So it indicates that it is a structure. So you have to use struct as it is. So be careful. S should be only small letter. S should not be capital letter. Struct and then tag. tag here refers to the structure name. Tag refers to structure name actually. Tag refers to structure name. Tag refers to structure name. Okay, tag refers to structure name. Tag refers to structure name. Okay, tag refers to structure name. And then the fields. What are these fields? These fields are nothing but which are part of the structure. Now, how do you define the field? They are nothing but the individual data items. So they can be integers, they can be characters, they can be arrays, they can themselves be structures. That is also possible. But how to define? So I'll just give an example. In fact, I think example is there. Let me just check. It is there in the. Okay. For the time being, I will give example. It is there in the subsequent slides. So it can be say structure. Struct. So the tag is nothing but structure name. So it is say student, and within this, so can have different fields. Different fields can be say integer roll number, and then so char name of some 20. So array. Okay, it is an array. So let us restrict ourselves to only these two fields. So you can have any number of fields like this. The syntax is struct followed by the structure name, which you can choose, and then within the flower brackets, you can different fields. Different fields are nothing but the individual data items. How to declare means it is similar to the declaration of the variables. It is similar to the declaration of the variables. In case of simple variables, say int, float, char, double, so followed by the variable name, that you can do. In the case of array, it should be data type followed by name of the array. Within the square brackets, you have to specify the maximum size. And again, they can be structures also. Within a structure, you can have a structure. You can have a structure that we'll see. So this is the general syntax. Try to remember always the general syntax. General format or general syntax, please try to remember. Okay. So as you go on do the programs, definitely you will automatically remember. But at the initial stages, it's better you have general format with you, maybe in the form of a paper. The field name should be different. Definitely you should not use two fields with the same name. Say integer roll number, again integer roll number. There is no meaning. The field name should be different. The fields can be basic data types, arrays, pointers, or another structure. So a storage class cannot be assigned to individual fields. Maybe it is little confusing for you. We are not discussing the storage class, but storage class cannot be assigned to individual fields. But entire structure, for the entire structure, you can assign the storage class. For the time being, you can just neglect this one. But okay, by declaring a structure, you are creating something like a data type, say like integer, char, float, etc. You are creating a data type. But if you have a data type, if you want to use them, what you are going to do, you are creating the variables. So int roll number means you are creating a variable roll number of type integer. So similarly, you have created a structure. Okay, Now you have to create the variables. For that you have to follow this syntax. Storage class struct as it is. If you want, you can avoid the storage class. It can be say auto, extern, etc. So let us try to avoid this one for the time being. Struct, the result word, tag, which is the structure name which you have already defined, and then the variables, that means, so if you have created a structure, say student, you can create multiple students, so say s1, s2, s3, etc. that you can do. So the other way of declaring structure variables, this is one way of declaring the structure variables. Struct followed by structure name followed by variable 1, variable 2, dash to variable n, separated by commas, terminated by the semicolon. The other way is, instead of using separate statement like that, here itself we can write. So what we have done in the previous case, we have put the semicolon, here, and then we have created the variables. Now what you can do is, you can add variable names here itself and then terminated by the semicolon, and then terminated by the semicolon. The tag is optional, but it's better you use it. So example, here you can see the example: student, integer, roll number, name, address, marks of a student. So that is the structure, and you can see below we are creating structure variables s1, s2, s3 of type student, that means we got three students. The other way, this is one way, semicolon, put the semicolon, and then after that you have created the variables. The other way is, here itself we can write. Processing a structure. Okay, you can represent the structure like this, you can declare a structure, but how do you use it? How do you process it? A structure field can be accessed by writing structure variable dot field. Period is an operator. It is a member of highest precedence. Period is an operator which is of highest precedence. So structure variable dot student field. Structure variable dot field. Okay, that means if you have, say, s1 is the structure variable and you want to access the roll number within that structure, then what you are going to write? s1 dot roll number. Okay, if a structure field is itself a structure, we are not discussing that one, but if it is the case, if a structure field is itself a structure, that means some other structure which you have already defined. So if you have, say, for example, name of a student can itself be defined as a structure, like consisting of the fields like first name, last name, surname, etc. First name, middle name, last name, like that you can create a structure, and you can make the name within the student as a structure type. If that kind of nesting is done, then structure variable dot field dot subfield, that is the syntax that is to be followed. We will discuss it when we do the programming. If a structure field is an array, then also you can access it by using the just structure variable dot field. But apart from it, because this it is an array, that field is an array, so how you have to access the individual elements of the array. In C language, we don't have any feature which supports us to access the entire array at a time. So you have to access only the individual elements of the array. That's why you have structure variable dot field. Here field is nothing but array name, within the square brackets expression. You can supply, say, 1, 2, 3, whatever it be. Okay. If the structure variable is itself an array, that means structure student is there. Instead of s1, s2, s3, I will call it as stud. So stud, I will call it as a stud of 20. That means here this is structure student stud. Okay, so that means this stud is an array where each element of the array is of type structure student, In the case of these structures, where you have this an array which is of type structure, then if you want to access the individual fields within this one, what you have to do, the array name expression dot field. That means, say in this case, say stud of say some 5 or I in general dot roll number. So little confusing until you get familiar, but as soon as you start typing the programs, doing the programs, definitely you will get familiar with this one. Okay, you will get familiar with this one. So for reading and printing, the usual rules apply. For in all the individual fields, if you want to read, the ampersand should precede while reading. Defining user defined types using Typedef. This is one of the good features. Maybe if whenever we write lengthy programs, we go with the Typedef. So we have basic data types, derived data types, and user defined data types. Okay, basic data types are int, char, float, double. Derived data types are nothing but array, structure, etc. So we are making an array as a homogeneous collection of elements, structure as a heterogeneous collection of elements, but the fields are nothing but the basic data types only. So it is derived data type. Now you want to create user defined data type. In fact, to be frank, you are not creating the new data type. Actually, you are not creating the new data type, but you are giving the new name. So remember, using Typedef, you actually don't create new data type, but you give a new name to the data type. So, but in books it is given as creation of new data types actually, but it's not correct. Okay, we'll discuss that. So Typedef can be used to define new data types. Once a user defined data type is created, the new variables, arrays, structures, etc. can be declared using new data type. What is the format? The format is Typedef followed by type followed by new type. That means Typedef, it is the reserved word you have to use as it is. Type is nothing but the original data type. So it can be int, char, float, it can be of type structure also. And then new type, it is user defined identifier. Type refers to the existing data type. This can be basic data type or another user defined data type. This is one example, simple example. Typedef int roll number. That means here what we are doing is we are creating a new data type called as roll number. Which is of type only integer, but we are creating a new type. After creating the new type, what we can do, instead of using integers, we can use this new type, roll number R1, R2. So as discussed, new data type is a new name only. All language specifications that are applied to the type will also get applied to the new type. So new data type is new name only. You are not actually creating the new data type. It is not possible to create new data type using structure. So that is one of the advantages of what is called as object oriented programming languages. We have object oriented programming languages like C++, Java, etc. In that there is a concept called as class. Using class you can create new data types, but using structure you cannot create. You can only create or you can give only new types. New types which have only new name. They have only new name. So we discussed this roll number example, but generally we don't create such trivial things. So we associate this typedef with the structure. Generally we associate the typedef with the structure. You can see here this typedef struct field 1, field 2, field name, etc. new type. So after creating this new type like this using typedef, the important things to be noticed here is new type, this typedef, and then new type. So after creating like this new type, then instead of using the original format which you are using, like struct, say if it is student, struct student s1, s2, etc. Instead of writing like this, now if this new type is of type say stud, if you give the name stud, then you can just simply write stud s1, s2, etc. So for large programs where we use the structures, we manipulate the record of information, we generally use typedef. Otherwise for small programs you can just remember the concept. We'll discuss if possible linked list. There we will make use of this one, a linked list in last module. Okay. So student stud s1, s2 we can create like this. So typedef theoretically is used to create new data types, but actually in C language we are giving only new name. That point you remember. So here you can see an example also. Typedef is used. So typedef is used, and then student. So after that you can create variables directly like this instead of using struct student, etc. If typedef is missing, if this typedef is not present, then what you have to do, every time if you want to create a variable, you have to write struct student followed by the variable name. So because here we are using typedef, so you need not again use struct. So you can directly create the variable student, say s1, s2, s3. So these are some of the references. If you want to, you can go through. Remember the references. These are the references for all the sessions related to structures, unions, and bit fields. Okay, bit fields. So because programming is all about manipulating the data, try to organize the data properly. If you organize the data properly, then the complexity of your solution, complexity of the algorithm decreases. Imagine 100 students are there, and each student having roll number, name, marks, etc. Then the best way of organizing the data is by defining the array of structures. That means you can define a structure called say student, and that can be, the variable can be declared as an array. So it is an array of structures. That is very simple. If you don't know anything about array of structures, then if you want to organize the data, So you will have huge amount of data, say roll number 1, roll number 2, roll number 3, raised to roll number 100, and then name 1, name 2, name 3, etc. So it becomes a complex thing. So organizing the data properly is very much important. You have separate subject called as data structures for it, but here also we'll be organizing the data. Here also we will be organizing the data. We are not going to study the pros and cons of organizing data in different ways. Okay, but we will be organizing the data so that the complexity of our algorithm is less. So thank you for joining. See you in the next session.